Hello. Today I'm going to talk about sensitivity analysis with LP. Sensitivity analysis is tracking the changes made to the model. The question becomes, when you change things in the model, do you get a new solution? Do the values of the x's change? Does the z change? But specifically, we're going to be talking about changes to only one thing in the model, one thing at a time. And then we'll look at the sensitivity report with Excel. When you make a change to the right-hand sides of a constraint, what happens is that the constraint will shift out or in, and it'll be a parallel shift. It's parallel because the slope's not changing. If it's a binding constraint, well, then the x's will change their values, and the z will change as well. If it's a non-binding constraint, the x's might change if it becomes a binding constraint. We're also going to talk about changes to the objective function coefficients. When you change in a coefficient in the objective function, a profit, for example, then the slope of the objective shifts. The z will probably change unless you're not producing that product at the current time. And the values of the x may change if the coefficient was changed enough to make it so. One thing that we're not really going to discuss in this presentation is what happens if you make changes to the coefficients within the constraints. I will tell you this, though, that the slope of the constraint will change, and you'll probably have new values of z and new x values if it was a binding constraint. If it was a non-binding constraint, well, if it changes the feasible region, then the x's might change as well. So let's start with changes to the objective function. First, we're going to define the range of optimality and then calculate it. The range of optimality is the interval associated with each coefficient such that the optimal point remains unchanged. So as long as you change your profit within that range, the x values aren't going to change. Of course, your profit's probably going to change, but the x values stay the same. To find this, you first figure out the slope of the objective function, which is minus c1 over c2. I should have a minus sign in front of there. And there are three steps. Step number one, find the slope of the two constraints that define the optimal point. And as long as the slope of the objective function stays within that range, then there's not going to be any change to the x values. But if we go outside that range, that's where the x's are going to change. So in step 2, what you do is you set c2 equal to the original value and solve for c1. In step 3, you do the reverse. Set c1 equal to the original value and solve for c2. So for example, let's take the table and chair problem again. Of course, the slope of the objective function is minus 4/3. The slope of the first constraint is minus 4 over 2, or minus 2. And the slope of the second constraint is minus 2 over 4, or minus 1/2. So that was step 1. Step 2, we set the c2 equal to the original value of 3, and then we solve both sides of the equation for c1. So c1 is equal to 6 on the left-hand side of the equation up there, and c2 is equal to 3/2, or 1/2. So the range of optimality is from 1/2 to 6, and as long as the profit on tables remains within that range, we'll still make 12 tables and 6 shares. If we go outside that range, well, then the solution changes. Of course, the z is going to change as well. In step 3, we set c1 equal to the original value of minus 4 and solve for c2. If I'm going too fast here for you, you might want to pause this video and do the math for yourself. So anyway, here the range is between 2 and 8 for chairs. And again, the interpretation is the same. Now let's talk about changes to the right-hand side. The shadow price is defined as the maximum you'd be willing to pay for an extra unit of that resource, or it's a change in z for 1 unit change in the right-hand side. Here's an example of how you could calculate it. Let's say that in the second constraint we change the right-hand side from 48 to 50. We get the new solutions. Then the shadow price is the change in Z divided by the change in the right-hand side, or in this case 0.666 was the increase in Z divided by 2 is 33 cents. So for every extra hour of production in Department B, our profit increases by 33 cents. Does that mean that 33 cents out to infinity? No, these shadow prices are only valid within certain ranges. And at some point, the other constraint will become the only binding constraint, and then after that, Department B's constraint becomes redundant, and the shadow price drops to 0 at that point. Here's a look at the sensitivity report from Excel. Notice that 33 cents on the bottom half is valid up to an allowable increase of 72. And that 33 cents is valid also on the downside, down by 18 hours. And outside those ranges, then the shadow price will change and it will be no longer valid. So if you had a choice between Department A or Department B for an extra hour, I'd go with Department A because the shadow price is higher. It's 83 cents. Also notice on the top half of the sensitivity report, you've got the range of optimality. The current objective coefficient for variable x1 was 4, the allowable increase is 2, so the upper range was 6, and the lower range was 1.5, 4 minus 2.5. So they don't give you the upper and the lower limits, they give you the allowable increase and the allowable decrease. But the interpretation is the same. So, let's look at the report. What if C1 changes from 4 to 5? Okay, we're currently at 4, the allowable increase is 2. So this change is within the allowable increase. Therefore, there's no change in the x's. We're still going to produce 12 tables and 6 chairs, but the z is going to increase by 12 to 78. Next question. What if the profit on shares decreases from 3 to 1? Looking back at the sensitivity report again, the allowable decrease is 1, and we're changing it by 2, so it's outside the allowable decrease, outside the range, so the x values are going to change. The z changes, it drops, but we don't know by how much. Next question. What happens if the right-hand side from Department A increases to 70? It was originally 60, so it's changing from 60 to 70. It's a binding constraint, so the x has changed. It's within the allowable increase, which was 36. Therefore, the shadow price is valid. The z changes, it increases, and we can use that shadow price, that 83 cents times 10, to get $8.33. Last question. What if the right-hand side Department A drops to 20? It was at 60. It drops to 20. That's a change of 40. It's a binding constraint, so we know the x values are going to change. But the allowable decrease on that variable was 36. So the shadow price is no longer valid. The z drops. We're not exactly sure how much it drops, but it's probably going to drop at least by 36 times 83 cents.
MASZ competition that are in the audio-video business. So it makes it, you have so much potential to really turn things into a gold mine not very easily, but if you put a little bit of effort into it. Because most site owners simply don't have the foresight to say, hey, I need to optimize for this niche, even though that might be a niche that they might have a business where they make a lot of money offline. But just not putting the effort into the keyword research and into the link building process, they're not going to know what's really there. And I also want to point out that these keywords that are bold and in green, these are suggestions. The ideal solution is that the owner of the business will look at this and say, you know what, these are some keywords here out of the, let's say 80 that are bolded and in green that are suggestions. Out of these 80, maybe 10 don't really apply to my business or my specific niche, whereas the other 70, or maybe the other 30 or 10 really, these are things that I specialize in that I really never thought about ever making a page for, or I really never thought about really putting an effort behind. These are the keywords that are ultimately going to make you successful. So again, my name is Steve Driscoll, and this has been my search engine optimization analysis for CypressAV.com, and I thank you very much for listening.